Welcome to the lesson on de-energizing high-voltage systems in battery electric vehicles. In this section, we will look at the guidance procedures to safely de-energize the high-voltage system in a BEV, focusing on the manual disconnect method. Let us look at our lesson objectives. By the end of this lesson, you will be able to list the steps involved in manually de-energizing a BEV high-voltage system. Next, you will be able to describe the steps involved in manually de-energizing a BEV high-voltage system. Later, you will be able to explain the purpose and procedure for disconnecting the 12-volt battery. Finally, you will be able to describe the proper use of the manual service disconnect, abbreviated as MSD device. The specific de-energization procedure will vary depending on your specific BEV model and the manufacturer's recommendations. This is an outline of the general steps on how to safely de-energize the high-voltage systems in BEVs using the manual disconnect method. It is crucial to follow these steps in the correct order. Please note that this is not an exhaustive list, and additional steps may be necessary depending on your specific service needs and vehicle model. Step 1. Keep the key fob away from the vehicle, as this prevents accidental activation of the electrical system. Step 2. Disconnect the 12-volt battery, as this isolates the low-voltage system from the high-voltage components. Step 3. Remove the manual service disconnect to disconnect the high-voltage battery from the rest of the vehicle. Step 4. Perform the live-dead live, abbreviated as LDL, test before testing the meter, as this test verifies the functionality of your testing tools before and after working on the high-voltage system. Step 5. Verify the adapter functionality. Step 6. Test the battery using the manual service disconnect test adapter in the socket. Step 7. Set the digital multimeter, abbreviated as DMM, to measure the high-voltage battery voltage. Step 8. Verify the high-voltage isolation using your meter to confirm that the system is safely isolated before proceeding. Step 9. Perform the live-dead live test to ensure your meter's accuracy after measuring the high-voltage system. Step 10. Put the adapter cover on the manual service disconnect to prevent accidental re-energization. Step 11. Confirm that the high-voltage battery charging port access is locked out and cannot be connected to external power sources. Step 1. Ensure the key fob is a safe distance from the vehicle, typically at least 10 feet or as the manufacturer recommends. This minimizes the risk of accidental activation of the high-voltage system by stray signals from the fob. Visually, check the vehicle to ensure it is completely off. Look for any instrument cluster illumination, headlights, or other signs of electrical activity. Follow the manufacturer's procedure to verify that the vehicle is not powered on. This is crucial for complete confirmation that the high-voltage system is de-energized. Each manufacturer might have specific procedures for verifying power down, such as checking specific indicators or using diagnostic tools. Always consult the manufacturer's service manual or instructions for the exact steps you need to follow for your specific BEV model. Step 2. Disconnecting the 12-volt battery is crucial in de-energizing a BEV before servicing or repairing the high-voltage systems. The purpose of a 12-volt battery is to power non-essential electrical components like lights, the infotainment system, and the instrument cluster. The 12-volt battery directly powers some electronic controllers of the high-voltage system. Even though the high-voltage system uses its own high-voltage battery, some control modules might rely on the 12-volt system for communication, monitoring, charging, or initial activation. Disconnecting the 12-volt battery isolates the high-voltage system from potential power sources, minimizing the risk of accidental activation. It de-energizes the electronic controllers, which might interfere with the de-energizing process. High-voltage systems often have backup capacitors that store residual voltage even after disconnecting the main battery. Waiting for the required time limit, as specified by the manufacturer, ensures these capacitors are fully discharged before proceeding with further de-energizing steps. This time limit can vary depending on the specific vehicle model and manufacturer, so refer to the service manual for precise instructions. Remember, never attempt to bypass safety procedures or disregard the manufacturer's instructions. Step 3. Removing the manual service disconnect is a critical step. The manual service disconnect is a physical device that isolates the high-voltage battery from the rest of the electrical system. Removing the manual service disconnect ensures the high-voltage system is completely isolated and de-energized, preventing any potential flow of electricity. Follow the manufacturer's specific instructions for locating and removing the manual service disconnect. It is usually located in a designated service area near the high-voltage battery pack. Use the appropriate tools the manufacturer recommends to safely remove the manual service disconnect. Visually, confirm that the manual service disconnect is fully disconnected and that the connection points are separated. After removing the manual service disconnect, wait for the specified time before proceeding further. This allows any residual voltage in the high-voltage system to dissipate completely. The waiting time varies depending on the vehicle model and manufacturer, so refer to the service manual for precise information. Step 4. Before initiating the power-down procedure, ensure that all meters and adapters are functional and undamaged. Perform the live-dead-live test to verify their functionality. This test is crucial to confirm that the tools are operational during testing and have not been damaged during the process. Before beginning the live-dead-live test, gather all meters and adapters that will be used during the testing process. Use tools and meters that are specifically designed for working with high-voltage systems. To perform the live-dead-live test, obtain a digital multimeter capable of measuring direct current, abbreviated as DC voltage. Set the digital multimeter to the DC voltage measurement mode by turning the knob to the appropriate setting. Insert the black test lead into the common, which is marked as the COM port on the digital multimeter. Insert the red test lead into the volts, which is marked as the V port on the digital multimeter. Turn the digital multimeter knobs to the DC volt symbol. Locate a known good battery, preferably on a workbench or another safe and stable surface. Connect the red test lead to the positive terminal and the black test lead to the battery's negative terminal. The digital multimeter should display the voltage reading. In this case, it should read around 12.6 volts for a fully charged battery. After confirming the voltage reading, turn off the digital multimeter. When the de-energization process is complete, repeat this process to ensure that all meters and adapters are functional and undamaged. Step 5. After removing the manual service disconnect, use a manufacturer-specific adapter plugged into the high-voltage battery socket. This adapter will connect to the high-voltage battery socket and provide a safe and standardized way to perform the live-dead-live test on the vehicle. Using the manufacturer's recommended adapter ensures compatibility and proper functionality within the high-voltage system. Following the manufacturer's instructions is crucial as it will specify the resistance measurement points on the adapter, the expected resistance values within a specific range, and the specific testing procedures using a multimeter or other tools. Remember, a malfunctioning adapter could provide inaccurate readings, potentially compromising the reliability of your measurements. Verifying its functionality before and after de-energizing the high-voltage system ensures you have confidence in the test results and the overall safety of the process. The adapter is a specialized tool provided by the vehicle manufacturer. It connects to a socket where the manual service disconnect was removed. Once removed, a dedicated socket remains accessible to connect the test adapter. The test adapter connects to specific points within the high-voltage system, allowing you to take reliable voltage or resistance measurements using your multimeter. Testing the battery using the manual service disconnect test adapter involves connecting the adapter securely to the designated socket. To measure the high-voltage battery, set your digital multimeter to measure the DC voltage in the appropriate range. Most BEVs have high-voltage batteries between 400 to 800 volts DC, so a range exceeding that is suitable. Connect the digital multimeter probes to the designated terminals on the test adapter or connect the digital multimeter probes directly to the high-voltage battery socket, ensuring you follow the manufacturer's instructions. Ensure proper polarity, red to positive and black to negative. Take the voltage reading. It should be significantly lower than the typical operating voltage of the battery pack, usually below 60 volts DC. A voltage reading below 60 volts DC indicates a safe state for further service or repairs. This suggests that the high-voltage battery is sufficiently discharged with minimal residual voltage. If the reading is higher than the manufacturer's specified level, it might indicate incomplete de-energization or residual voltage concerns. Consult the manufacturer's service manual for further guidance. Step 8. Follow the manufacturer's instructions for measuring the voltage between the high-voltage system, typically measured on the test adapter, and the vehicle chassis or ground. This might involve specific connection points or procedures depending on the model. Ensure your multimeter is set to measure DC voltage. Take the voltage reading. The voltage reading should be significantly lower than the typical operating voltage of the high voltage battery and within the manufacturer's specified safe isolation level, which is typically below 60 volts. Isolation faults occur when a path is created between the high voltage circuit and the vehicle chassis or ground. This can be caused by damaged wires, loose connections, or internal component failures. Even a small voltage reading above the safe level can indicate a potential isolation fault. This poses a safety risk and should be addressed before proceeding with any further work on the high voltage system. Remember to never proceed with high voltage service or repairs if the isolation voltage is above the safe level. This indicates a potential fault, and further investigation and repair are necessary. Verifying isolation before each service step is crucial for safety and preventing damage to the vehicle and yourself. Step 9. After you have verified that the high voltage circuit is de-energized, as mentioned in Step 7, and isolated from the chassis, as mentioned in Step 8, the next step is to check your tools again to ensure they haven't been damaged during the process. This ensures the functionality and reliability of your measuring tools, including meters and adapters. Even though the high voltage system is de-energized, completing the dead live test again provides additional confidence and eliminates the possibility of tool damage during the process going undetected. To perform the dead live test, refer to your manufacturer's specific instructions for the exact steps and test points. Step 10. Ensuring complete isolation from the rest of the vehicle's electrical system is paramount. This prevents accidental re-energization, minimizing the risk of electric shock or damage to the vehicle and equipment. The manual service disconnect serves as the main isolation point for the high voltage system. The special adapter cover provides an additional layer of safety by preventing accidental reactivation of the manual service disconnect. This adapter cover is designed to fit securely over the manual service disconnect in the locked out position, be visually identifiable as a lockout device, and have no electrical contacts, eliminating the possibility of accidentally re-energizing the system. Remember to never skip or bypass the manual service disconnect lockout procedure with the special adapter cover. Confirm that the manual service disconnect is securely locked out and that the cover is properly engaged before leaving the vehicle unattended or performing any post-service checks. Ensure everyone working on the vehicle is aware of the importance of lockout. Additionally, refer to the specific instructions provided by the vehicle manufacturer for your BEV model regarding the manual service disconnect lockout procedure and the use of the special adapter cover. The exact procedure, cover design, and location of the lockout points might vary depending on the specific vehicle. Step 11. After de-energizing the high voltage system, verify that access to the high voltage battery charging port is locked out. This prevents accidental energization from external sources while the vehicle is unattended. Even with the high voltage system isolated internally, the charging port remains a potential point of access for external power sources. Locking out the charging port physically prevents the connection of charging equipment, eliminating the risk of accidental re-energization and ensuring continued safety. The lockout mechanism varies depending on the vehicle manufacturer and model. Consult the manufacturer's service manual or documentation for specific instructions on locking out the charging port for your vehicle model. For example, Volvo has a specific tool required to lock out the charging port of a particular model of their BEV. Once you have implemented the required lockout procedure, visually confirm that the charging port is locked and cannot be connected to charging equipment. Document the lockout status for future reference. By completing this step, you can be confident that the high voltage system is fully isolated and locked out internally and externally. This creates a safe environment for post-service checks, further repairs, or leaving the vehicle unattended. Here's a recap of the 11 steps on how to safely de-energize the high voltage systems in BEVs using the manual disconnect method. It is crucial to follow them meticulously and in the correct order. Please note that this is not an exhaustive list, and additional steps may be necessary depending on your specific service needs and vehicle model. Always refer to the manufacturer-specific instructions for safe de-energization. Step 1. Keep the key fob away from the vehicle, as this prevents accidental activation of the electrical system. Step 2. Disconnect the 12-volt battery, as this isolates the low-voltage system from the high-voltage components. Step 3. Remove the manual service disconnect to disconnect the high-voltage battery from the rest of the vehicle. Step 4. Perform the dead live test before testing the meter, as this test verifies the functionality of your testing tools before and after working on the high voltage system. Step 5. Verify adapter functionality. Step 6. Test the battery using the manual service disconnect test adapter in the socket. Step 7. Set the digital multimeter to measure the high voltage battery voltage. Step 8. Verify the high voltage isolation using your meter to confirm that the system is safely isolated before proceeding. Step 9. Perform the dead live test to ensure your meter's accuracy after measuring the high voltage system. Step 10. Put the adapter cover on the manual service disconnect to prevent accidental re-energization. Step 11. Confirm that the high voltage battery charging port access is locked out and cannot be connected to external power sources. Let us look at our lesson summary on de-energizing high voltage systems in BEVs. De-energizing begins with securing the key fob and disconnecting the 12-volt battery, which helps disable controllers and communication paths that could activate high voltage systems. The manual service disconnect must be safely removed and visually verified, as it physically isolates the high voltage battery from the vehicle's electrical system. Performing dead live tests before and after measuring high voltage battery voltage and isolation ensures your tools are functioning correctly and confirms that the high voltage system is safely de-energized before service work begins. Measuring voltage and verifying high voltage isolation using manufacturer recommended adapters is essential for detecting residual voltage or potential isolation faults. Final lockout steps, including applying the manual service disconnect adapter cover and securing the charging port, prevent accidental re-energization and ensure a safe working environment. Thank you.